This videotape will familiarize you with the mechanics and functions of the common accessories for the engine lathe. You should understand that you are not expected to be proficient in the use of these accessories, but rather to have a clearer understanding of the nomenclature and purposes of these important attachments. After watching this videotape, you should be able to perform the safety procedures required in every machine shop, identify the accessories you will be shown by their proper names, describe the generally accepted uses of these accessories. When you are in the shop, you have to take some precautions that will protect you and the people around you. Always wear your safety glasses. Take off all jewelry, such as rings and watches. Roll your sleeves up above the elbow, and make sure your clothes fit close enough so they won't get caught in the machine. Most common machining operations require some kind of work-holding device. The most common holders are chucks. We will look at the 4-jaw independent chuck, the 3-jaw universal chuck, and various collet chucks. The 4-jaw independent chuck is heavily constructed and well suited for holding cylindrical or irregular shaped workpieces. It is generally used in operations requiring large, heavy cuts. As its name would suggest, the 4-jaw independent chuck holds the work in the 4 jaws that move independently. These jaws can also be removed from the chuck independently. When the jaws are out, it is very convenient for you to remove any chips from the jaws and screws. This should be done periodically to prevent wear. You can also reverse the jaws in the chuck to hold workpieces of different shapes and diameters. As you see, the 4-jaw chuck is well suited to hold an irregular workpiece. 2 of the jaws have been reversed to hold this irregular workpiece. This is a 3-jaw universal chuck. The jaws move in or out simultaneously and are always the same distance from the center. Because the jaws move together, the 3-jaw chuck can be relied on to keep the work properly aligned. It is, however, limited to holding cylindrical workpieces. When you remove the jaws for periodic cleaning, use the following procedure. Back the jaws out as far as possible. And when the scroll is properly aligned, remove the number 3 jaw first. Then you remove the number 2 jaw. And finally, you remove the number 1 jaw. These jaws will be stamped with numbers 1, 2, and 3 that will match numbers stamped on the slides. Wipe the jaws and the scroll with a clean rag. And oil the scroll lightly. If the scroll is oiled too heavily, the rotation of the chuck will throw out the excess oil. While the jaws are out of the chuck, let's look at 2 ways of reversing the jaws. This chuck has solid jaws, which must be replaced with a different set. The chuck and the jaws are marked with a serial number. These numbers have to match for the chuck to work properly. To replace the jaws, you reverse the removal procedure by lining up the scroll and inserting the number 1 jaw in the number 1 slot. Next, You insert the number 2 jaw in the number 2 slot and the 3rd jaw in its slot. To check for proper alignment, close the jaws completely. As you can see, these jaws are all in alignment. If the jaws are out of alignment, the workpiece will not turn on center. To correct misalignment, remove the jaws and repeat the procedure, making sure you insert the jaws in proper alignment. Another method of reversing the 3 jaws is by this jaw, commonly called the split jaw. To reverse this type of jaw, you use an Allen wrench to back out these 2 screws. Then remove the top half of the jaw. Clean the jaw parts thoroughly to prevent chips from spoiling the alignments. Now reverse the jaw and replace the 2 screws. The split jaw saves time because realignment is not necessary. Here are 2 typical workpieces being held in a 3-jaw chuck. Both the 4-jaw and the 3-jaw chuck can grip work from the inside. Here, a 3-jaw chuck is holding work in this fashion. You must be cautious with this kind of setup because the jaws do not have much holding power in this position. For holding cylindrical workpieces, you may want to use the collet chuck. Collets come in 2 varieties: the split collet and the rubber-mounted collet. Work held in the split collets should be within 0.005 inches or 0.2 millimeters of the collet diameter. The split collet holds the work by being pulled into the taper of the spindle by a drawbar or a hand wheel. Here is work held in a split collet. The rubber-mounted collet allows for more variation in diameter. The work is tightened in this collet by tightening the hand wheel. Here is work held in a rubber-mounted collet. For clamping thin or irregular shaped pieces of work, you can use a faceplate. This work is clamped to a faceplate for offset drilling and boring. To drive work being turned between centers, a drive plate and lathe dog can be used. The lathe dogs, which come in different sizes, fit over the workpiece and into a slot on the drive plate. This is a dead center mounted in the tailstock. A center is considered dead when it does not rotate with the work, but provides support for it. This special dead center, called a half center, allows work held between centers to be finished to length. This is a ball-bearing live center that can be used in the tailstock. It is considered a live center since it turns with the work. This type of center prevents the center hole from wearing and causing misalignment. For drilling on the engine lathe, fit a drill chuck in the taper in the tailstock spindle. Drill chucks are used for holding center drills. Also, twist drills up to 1/2 inch in diameter. For drilling large diameters, drills with tapered shanks can be fitted directly into the taper of the tailstock spindle. If the shank is too small, you can use a drill sleeve. also called a socket reducer for proper fit. The micrometer stop is a device which is clamped to the ways to accurately measure travel of the carriage. Here you see it being used in cutting a shoulder. The follower rest is used for long, smaller diameter work to prevent it from flexing away from the tool. As you see, the follower rest is clamped to the carriage, allowing it to maintain its support opposite the tool throughout the cutting operation. The steady rest can also be used to support flexible workpieces, but it does not follow the tool because it is clamped to the ways. The steady rest is more commonly used to support the end of long workpieces. The taper attachment is usually bolted permanently to the bed of the lathe. It has graduations on each end for cutting a desired taper. One end is calibrated in degrees, and the other end is in inches of taper per foot. There are 3 common tool holders you will be using: the left hand, the right hand, and the straight. They are so marked on the side. Here you see a left-hand tool holder and a right-hand tool bit mounted in the standard tool post. In addition to the standard tool post, there are 3 commonly used specialty tool posts. The open side tool post usually holds carbide cutting tools. The turret block tool post holds up to 4 tools which may be swiveled into position for quick tool changes. The quick change tool post is another device for rapid changing of preset tools. In many operations, it is faster and more convenient than the turret block tool post. The tool post grinder can be attached to the compound rest for specialized grinding operations. Here you see it being used to regrind a lathe center. This tracer attachment allows you to duplicate pieces accurately. Here you see it reproducing a contoured piece. You have seen some of the more common lathe accessories. You should be able to use the proper nomenclature for these accessories, and you should also be familiar with the way they are used in the machine shop.